Hey crafters, welcome back to Control Crafting. I am Amal and today we are going to crush LeetCode problem 26. So that is remove duplicate from sorted array. So what we will see in this video is like we are going to see two approaches to solve this problem. And we will first discuss the problem and then we will discuss the two approaches, their time complexities also, and we will see which approach is better fitted. So let's get into the problem. This is our problem statement. As you can see, the level is easy right now. So we have an integer array nums sorted in non-decreasing order. So by non-decreasing order, it means it is sorted in ascending order. Remove the duplicates in place such that each unique element appears only one. So what we have to do, like we have to remove the duplicate elements and just keep only one occurrence of that element. The relative order of the element should be kept the same. Okay, the relative order, that is if first come first in the array, and it is since a like sorted array in ascending order, therefore it's like the order should be the same. I mean, for one it should come before two, not after it. Like I can't return 2 comma 1 if my array is 1 comma 1 comma 2 comma 2 comma 2. So I should maintain the order of the elements. Consider the number of unique elements of nums to be k to get accepted. You need to do the following things. Okay. Change the array, just see this line, change the array nums such that the first k elements of nums contain the unique elements in the order they were present in nums initially. Okay. So what's the statement saying? That we have to, I have an array nums here, 1, 1, 2. As you can see from example number 1, then what I have to change my array nums to first such that the first k elements of num. So what is k here? The unique elements. How many unique elements do we have here? 2. That is 1 comma 2. So the first k elements of nums contain the unique elements in the order they were present in nums initially. So what's the order of 1? It is before 2. So it should be also in the same order. The remaining elements of nums are not important, as well as the size of nums. So whatever the remaining elements of nums will be there, it's not important. Moreover, its size is also not important. So this is the first thing that we have to do in this question. And the next thing is we have to return k. So what's k? The number of unique elements. So what we have to do, we have to return how many unique elements we find in the array. Now we'll look at the two examples and we will see like how this question is asking us like how we are going to generate our output. Nums is 0, 0, 1, 1, 1, 2, 2, 3, 3, 4. So how many unique elements I have? 0, 1, 2, 3, 4. And since the order is also preserved for 0, 1, 2, 3, 4 and the value of k is 5. So explanation is your function should return k is equal to 5 with the first 5 elements of numbers being 0, 1, 2, 3 and 4 respectively. Since it's written respectively, therefore we should maintain the order, and it is also mentioned in the question. It does not matter what to leave beyond the returned k, like after k, whatever we have, it doesn't matter. Hence, hence there are underscores. So this is our whole problem statement. So moving to our approach one, that is set. So whenever I have to remove some kind of duplicate elements and return a unique set or unique list, then the first thing that come up in my mind is a set interface. So, but in set we have some limitations which will not be fulfilled here, like in the question, whatever it demands right now. So what we are going to use, we are going to use linked hat set. So what is it, what's linked hat set? It is a type of set that maintains the order in which elements are added to it. So our question just have a special condition that I have to maintain the order in which the elements have been added. So, okay, and as per the definition of set, it will only contain unique elements, not any duplicate elements. So this is my first approach that I'm going to follow. So now we are going to implement the set interface approach. So set, I have integer type, and then I'll name my set as unique set, and then calling the constructor of linked has set. Okay, then for int n in nums, what I'll say that I will add those in my set. So uset dot add, uset is unique set. I will change the name because it's not a good practice. Unique set, okay, unique set dot add what n. So now only unique elements I have in the set and the order is also maintained. Now int I is equal to 0 for int n in unique set. What we have to do, we have nums I plus plus is equal to n. So now we are iterating the, first of all we iterated the array that's given, and now we are iterating the set, and like I have index I is equal to 0, and whatever the length of the unique set would be, up to that I, our elements will be stored because int n is keeping a track of it. And since I have to return the, what I have to return, k, and what's k? Unique elements, number of unique elements. So I just have to return the size of the set. So return unique set dot size. I'm done with my code. Let's run it. Oh, okay. Small spelling mistake, but that's okay. So my code is accepted by the test cases. Now I have to submit it. So as you can see, my code is taking 4 ms and it's only beat, it has only beaten 8.43%. So let's understand why this is happening. Going to the time complexity calculation of our set approach. How we are going to calculate the time complexity is first of all looking the for loops that we have, and we'll see how many times these for loop run in our worst case. So what will be our worst case in this question? That nums is equal to 1, 2, 3, 4, where all the elements are unique, none of them are repeating. How this is worst case? Because the resulting unique set will be equal to our num according to the conditions. If we look at this for loop, we will see that it is running up to the number of elements nums has. So here nums has 4 elements. Similarly, this second for loop will run for the number of elements present in unique set. In the worst case scenario, this will also has 4 elements. So how we are going to calculate it in terms of a variable? Whenever we are dealing with the size, we usually define it as n, where n is the size of the array or the list, whatever you want to take. Because the size of nums can be 4 elements, can be 5, can be 100, and can be 1000. So for a universal understanding, we take it as n. If we look in the code, like line number 4 for loop will run for n times, and line number 8 for loop will also run for n times. That is 2n times. But in order to calculate the time complexity, we ignore the constant value, we ignore the lower bounds. If I have to calculate time complexity, then we will find the average time complexity will be order of big O of n. I hope I'm clear on this point, that this for loop, our first for loop is running n times. Similarly, our second for loop is also running n times in worst case scenario, resulting time complexity to be order of 2n, that is approximately equal to order of n. Now let's get into the space complexity. Let's calculate it. Since we are using extra space in creating a unique set, I have just mentioned that in the worst case scenario, unique set length will be equal to num's length. Taking the worst case scenario in mind, the space complexity will be order of n for this code. The next approach we are going to see is two-pointer approach. You might ask, what is two-pointer approach? Two-pointer approach is the process in which we will access two elements at the same time. In order to see whether an element is equal to or greater than or smaller than the previous element or whatever the position we want to access, for any linear data structure, we use two-pointer approach to make our solution optimal. Let me take you an example of an array 0, 1, 3, 10, 9, 7. And I want to find the minimum number in the array. By two-pointer approach, what I can do, I can have my I here and I can have my j here, and I will iterate my array. So what condition do I have? If array of I is less than array of j, then minimum is equal to array of I. Here what I'm doing, that I am comparing two elements from the same linear data structure. This kind of approach that we're looking is called a two-pointer approach. Now just coding it around a two-pointer approach. So I have int I is equal to 0 as discussed, and I'll have a for loop for j starting from 1, and j is less than obviously nums dot length j plus plus. So this will be my for loop, and I'll check if nums of j is not equal to nums of I, then what I have to do, if it's not equal, then obviously it's not a duplicate element. Therefore, I have to retain that value. So I'll do one thing, I plus plus. Here, I'll just increment the value of I, and nums of I is equal to nums of j. So as I have told you that I will increment the value of I over a condition, only then its value get incremented, and j is in the for loop. So this is the two-pointer approach. I am iterating the array by one for loop, but I have my two pointers here. So that's it, and I have to return k, right? So I will return I plus 1. Why? I'll just tell you in a bit. Okay. So here what I have done, like I have initialized I is equal to 0. Then for nums j is not equal to nums I. So j value is 1 here and I value is 0. So first comparison is done. I will change I plus plus because I want to fill my values from num index 1, because num index 0 will always be unique. We do not change the first element of the array, we will start from I is equal to 1. We'll start changing it from I is equal to 1. Therefore, for the first element of the array, I am returning I plus 1 for this size. Okay, so let's run this code and see whether we are doing it correct or not. Yes, my test case is passed, and submitting the code. And now we are beating 70.55% and my runtime is 1 millisecond. So you can see that it is a most optimized version of the set problem, like the set approach we had. So let's study about this time complexity. Looking at the time complexity and space complexity of the two-pointer approach in order to find out how our code get optimized. If we see our first for loop, that is on line number 4, we can say that our for loop runs from j is equal to 1 to j is less than nums dot length. Let's have nums dot length equal to n here. So j is less than n. Okay. Can we say it is running for n times? Yes. This set of code 5, 6, 7 will run for n times. So the overall time complexity for this code will be order of n. Now looking towards the space complexity. we have, you can see we do not have a space defined in this approach. We manipulate the same input array that was given to us. We are iterating the same array that was given to us. So the space complexity of this code is order of 1. The decreased space complexity helps us in achieving optimal solution. The set approach time complexity was same as the two-pointer approach time complexity, but the space complexity for set approach was order of n. This is the reason for our optimal solution. Thank you for watching this video. I hope you liked it. Thanks for the patience. मिलते हैं अगली वीडियो में, तब तक के लिए बाय बाय।